Recording. Okay, that's running, and let's open our project. We will continue on our custom string class, and what we will want to add today will be a few very useful functions: a split function and a join function. These functions allow us to split a string into a list of strings based on a either separator character or separator substring, and then join basically does the reverse. It allows us to join a list of strings into one long string, and we can specify a character to be put in between when we are joining it. The complication with this feature is that to do it we need some sort of list. We of course could just use STL lists, but since STL already has a string, then there would be no point in having our own string class. So what we need is an own list class. So I'll implement a very basic list class, and then we can use it, and later we may also add new features to this list class, so that will give us more opportunity to implement some additional functionality. So let's call it xlist. And it was supposed to be a header file. Rename. Oops. Okay. And similarly to our x string, we will make it a template, so we can at least copy some code, so we don't need to type too much. Say xlist. And the destructor for that, and that's that. Oops. That's that for now. So the list will need to contain, like our string, some internal structure that will then contain our elements. There are many ways how such lists can be constructed, and it's always a trade-off between efficiency and memory usage. So, and of course also simplicity. So in this case we'll go for a very simple implementation where we have a linked list. We'll later extend it into a doubly linked list. What that means you will see in a second. So first we need a struct that will contain one element of the list as xlist entry. We could also just call it as xentry. And the entry contains, of course, a pointer to, or it also can contain the actual data depending on how we want to design it. In this case, it is probably more efficient to use just the type directly, which is our data. This way we don't need to allocate memory twice. We only allocate one as entry, and then we apply copy. Since we are not intending to pass to the list pointers which could be ownable, then this approach is the most convenient. So we have our type, and then what we also need is a pointer to the next element in the list. So as I said, it's a linked list, so basically it means that you have an element which contains some data, and then contains a pointer to the next element, like a chain, and then this points to the next, and the next, and the next, and the next, and so on. The main downside of such a type of list is that we cannot simply access an element at a given index. This would require a different sort of data type, but I think for now let's go with this, and if we want a different data type we can then implement a X factor later if we have enough time. That would give us the ability to address elements by index. So we have data, and then we have our p next, and as I said, we want to make it a doubly linked list later, so there will be a previous pointer as well, but for now we will not do anything with it. And we of course always initialize everything to be on the safe side. So our main object will only require two pointers, a head pointer which points to the first element in the list, and later when we make a doubly linked, we will also add a tail pointer that will point to the last element, so that we can start iterating through the list from both ends, so that we don't have to always start at the very beginning and then look where the end is, but we can actually start from the beginning, start from the end. And the main advantage of such a linked list is that it has a very good performance when inserting elements at the ends. And usually for text parsing, that should be enough. That we just break something into a list and then we take one token after the other, and so on. So we have here our elements. The list doesn't do. There's a question. Okay, that's not a problem. Right, let's continue. So we have our list, and now what we'll need is, of course, a way to add an element to the list. So void append, it takes a const t reference value, and now the question is how we want to operate. Do we want to append at the beginning, or do we want append at the end? And of course, appending at the end is not the most simple thing, since as here we don't have a pointer to the end yet. But what we can do is, it's not super efficient, but we can find the end pointer. So just take a list entry equals reference head form we can later step through it if you want to see how this works in detail. There is no body to this loop, and at this point we should find the tail, which then will be, so it works like this. We have a pointer on a pointer, so we have a pointer on a variable of this type, and first we assign it the head, and if the head is null, then we are done. If that is not null, then we take the next from the inside and again get the pointer. So here, when we modify ptail, we either will modify head or we will modify next in the last element in the list. And we also know that ptail at this point is null, so the memory that it points to. The syntax, there's a question in the chat. So the asterisk means to access a pointer as if it would be a local variable. So you can get the data that the pointer points to, or you can assign to the memory where the pointer points to. So in this case, if we assign now to asterisk ptail, we will be overwriting either pnext in one of the elements or phead, depending on what the state of our list is. So here we will make a new as entry, and now we can assign data with our, let's call this to be consistent, also data with our data. And at this point we should already have everything in the list, so at least for adding elements. So let's make a very quick test case here. If this works, and once it works, then we will proceed to doing something with our string. Or maybe first we'll then also add a way to enumerate the list. That might be better. So cx list, let's go with integers, int my list append 1 2 3 And the nice thing about templates is that we can either use a simple type or we can use any type, like a whole string. So it's really quite flexible. So let's put a breakpoint somewhere at the end. Okay, it doesn't like something. I've got the asterisk, so here again we need to dereference p-tail before we can get the p next. Okay, there is so let's inspect it. So we have our list. We have the head element, it has data 1, the next is data 2, the next is data 3, and the next is null. So as you see, the list already works. There's another question in the chat regarding the code. So was it? The semicolon doesn't mean anything with regard to the asterisk. It just is a separator in the for loop. So we have a loop, and in the for loop we have always 3 places. The initializer here, and then we have here the condition, and at the end we have something that gets executed after the check was passed and after the loop body here was executed. Okay, so that resolved that question. So right, and let's maybe really add a way to iterate through the list. So we will make here a in principle, to make this elegant, we need the entry to be accessible. The entry to be accessible from the outside. So we'll make an entry get head, which will just return head. And in order to not make this to not allow direct access to the internal elements of the next, we will just create here a next function which takes the previous and it just gives us the next from the thing. And the way this works is here that the next internal is private, so outside of this class we can only access data and nothing else about the S entry. We could do one improvement. We can make it like this, such that if there is a memory overrun in tdata, that we don't directly destroy our p next. I mean, we should of course always avoid accessing invalid memory, but I think this is just more elegant because it adds a certain level of additional fail safetiness. So let's see how we use this. For say we can use either this syntax, which is a bit longer, or we use a nice C feature which allows us to automatically get the right type from whatever we are doing. So get head, then we must check if this is null, because it might be null, so we just check that this is not null ptr, or we can just leave it like this, as this also checks for nullness. And once we are done doing what we were doing, we can then get the next entry. What we can later do is we can implement a proper iterator mechanism, such that you can use ranged loops and in principle a portion of STL's functionality that works with any container that uses iterators, but that would require yet another helper object. So for now we want to keep this as simple as possible, so we don't do that. Comma data. And as you see here, we can only access data, we cannot access the other member, which means that we can rely on being able to modify those things and their behavior as we want. So usually when you create a library of some sort that exposes some interface to the user, even if you tell the users only use this or those functions in certain ways, people will just do whatever is possible, and then you might find yourself that they use some internal implementation artifact of your library, and then later you cannot change this without breaking code compatibility with the old code. If you, however, guard with protected and public and private keywords your members properly, then you can ensure that you can enforce that the user of your library will only use those portion of its implementation that you deemed to be constant and that you don't intend to change in future, while you can protect all the things that you say today it's like this and tomorrow it might be completely different. Good. So since we have our list already, we can iterate through it, we can add to it at least from one end, which should be already good enough. So now the task will be to implement here this split and join functions. So I write the function prototype, and you can already think whom of you would like to try to implement that. Okay, so hash the X list, and we start with the split function, obviously, which is x list string split, and then we would add a separator const reference that needs to be specified, so that we specify by what we are splitting it. And of course in the end we want to return a list, and in the middle is the to do. So any volunteers? Okay, yeah, sounds good. Let's try it. Is the connection connecting? Is this oh wait, that will not work. One moment. The network is not configured as it should. That should be the right one. Okay, that's the right network. Just quickly check whether the IP is correct, or whether that one changed as well. Should be right. Try connecting again. Oh yeah, because it changed. That IP changed as well. That's unfortunate. Where's the chat here? 5100. Try this one. That one must work. It's in the chat as well. Okay, so I can write down a short example. What we expect. So what we want is we have some string. Let's say x2 my star is equals, let's say, yeah, a comma or a string. So it can be more than one character, and you can use the already implemented substring and find functions to iterate through the string and put portions into our list. No, we have our list already. We want to put the sections inside the list. So we start with the string as provided in line 153, and then we want to create out of it 3 strings, all contained in the list. One string being 1, 2, 3, the other string being 4, 5, 6, and the last string being 7, 8, 9. Yes? In principle, you can, because we have the substring function, so you only need to have the offsets, and then you can say substring from to, and the result of the substring will be then appended to the list. You don't need to explicitly introduce a temporary variable. Looks like it. Yeah. Well, it was a bit more complicated because we needed to have like the double point and the backslash, and here we only need one that we are looking for. No, when you call find, then it's automatically on this. It doesn't take this as argument. It takes the what we are looking for and the position. That's the nice thing about objects, that your functions are automatically can access the objects on which they are defined. You don't need to pass it each time. Like with normal old school C, you would have, if you would make the list, and every function would need to take the list as an argument again. So that would not be ideal. Yeah. Mm-hmm. Well, mm-hmm. Yeah, you will need to for the next iteration go one further. You use another temporary variable into which you save the current result of find, and at the end of the loop you update last position with what you got plus one. This way you can ensure that you will not miss the first character, because you have this distinction between the first run and all the subsequent runs. That would solve that issue, but you still will need another temporary variable. But proceed. Let's see how it goes. It takes the position and then the length as arguments. Well, we also we need something that starts at 0, because you also want the first string 1, 2, 3. Um, that, I think that can be made more elegant, because you start with, so we start with from position, and you could have from position as the argument in your find, so that you look for in line 163. You use from position as an argument in the find as the second argument. Okay, so then we have from to 2. Yeah, but but then you need to of course you need to check when we are done, because this way the loop will never terminate. -1. Mm-hmm. Yeah. Mm-hmm. List append substring. Now we need a test case in main and see if it works. No, as like in the example, yeah. Yeah. Now we just need to fill it in with something. Mm-hmm. I just realized I think there is a bug but in the code, but we will see it shortly. No, list from cx string from char, like a template from a template. Cx string, the whole type is the argument for the next template. That's why this auto keyword was introduced, because I mean this is already long, but you can have really like 100 characters of type definitions if you're using templates of other templates, and at some point it just doesn't really make sense, so we just write auto and that's it. Here we have not specified char because cx string without a specification is of whatever type the parent template is. So here we don't. Yeah, we can do that, yes. But then also in the definition in line 157, cx string. But as said, it's not necessary because it will automatically take their own type. Yes. Oh, I forgot to make a copy and assignment operators for the list. That will not work. um, it will work because we also did not clear the memory, but it is absolute garbage. So you can try it like this, but I will need to fix that later. It will work, but it will cause a memory leak. But just for testing, it's fine. Yes. Set complaints. Yeah. Click on the first line. Okay, wait, that's strange. Let me have the mouse for a second. Oh, here. You lost a... Yeah. Okay. You need to change the %t with %s, and after data add data dot c string, because we want to access the internal c style string of the object. Okay, better. I have the mouse again. Weird that this worked before. and we don't want data, but as you see, it's kind of not really doing what it should be doing. So it needs to be corrected. Still, the split function is not splitting the right way. So let's see, we have the first is value 1, and then the next one is value 2 comma, wait, we have, yeah, right, this. So this ones we can ignore because it's from the upper loop, but this one's here, as you see, it's it seems that something is wrong with the offsets. I just commented this out, we don't need that. Once this is fixed, we can look into properly fixing our list object. It's one of the windows at the bottom. You need to open it. Yes. Also, it misses the last value, so we should have four entries in the list, and we only have 3. The substring takes as first argument the position, as a second argument the length to be copied. So it should not be position. Yes. Almost. I think without the +1 it will be stuck and always do the same thing. It's because the last one is not terminated with a comma. So for the last entry, you will get the 2 position, which is -1. It's a special case. Well, it needs the special case to be added because we wanted to give us all 4 entries in the end. And there was another small mistake when you look on the return data. The first value starts where it should. The next one starts like shifted by 1 character. When you look on the result data, open again the window. Oh, that's the other window. You need to run it again. I think you closed it. You see that the value 2 and 3 are shifted by 1 character. Because from the string you are looking for, you take the last character of it, which is not correct. Nope. Separation can have any length. You don't know what length it has. Also, you don't need to do that in the first iteration. Then you would be cutting off. So you need 2 special cases for the first thing you found and for the last thing you found. And let me think. And this should be doable without like writing without having special variables indicating that. I'm sure that you can find a way to. I think you can find a way to do that without having like a first variable, because you can just check if from position is 0. Because if from position is 0, then you know implicitly that it's the first go. I think this will be off by 1 because we use +1 at the bottom. You could simplify it. Instead of adding it here, you could replace a +1 with sep length. Then you don't need a special case. So in line 170, just add sep length. And this takes care for the position. That might be working. Let's try it out. Well, it will still not print the last value, but it might at least, it should at least solve the offset issue. Yep. So now we just need to find a way to make it work for the last case. Oh, it must be higher up. You can yeah. You could add length minus, but you can also just remove this argument because we have the option of a -1, which just takes the string until the end. So if you just make substring from position without the second argument, that should already do what we want. Yep, perfect. Very good. So the next thing we will want to make is the opposite one. So maybe Mr. Clements would like to do that. Okay, then I'll just quickly prepare the for the join function. So this will this technically will be a static function because it does not return, it doesn't modify the current object. We just want basically to do the opposite. Cx string char join my list punct c string. Right, and since we are using here a reference, we are not copying it around, so we don't need yet to repair the CX list, or rather to complete the CX list. So you can start with this implementation, and when it does what it should do, it should work fine. The argument is a list. Wait, we need a second argument, an optional argument, because we want to join with something so that we can optionally specify, let's say for example a semicolon and the space. But this is optional, so this can also be empty, in which case it will just add everything together without a separating character. We have a list of strings. Mm-hmm. Yes, that's the sub value that then will be put in between. Mm-hmm. Mm-hmm. And you will need some temporary variable to hold the return value. It's a CX string. It will return a new CX string. It just is a so the CX string is a template, and in the triangular brackets you specify from which type this template is to be generated. Also, in more complex templates, you can have multiple template arguments. So we only have t, but if you look on the STL, you will often see that it also can be created. Like for example, a map will have two arguments, a key and a value, and so on. Yes, you can look in main how that works. You can copy. No, it was at the bottom. The active code, line 80 and 81. So the whole loop is basically just line 80, and line 81 does something with the current element in the list. P next. That's quite completely inverted of what it should be. The append function must be called on join string. Just p next without the reference operator, and it's a pointer pointing to an internal structure of the list. You need to use arrow data on it to retrieve the actual data. Capital D, yes. Not sure why the IntelliSense is not helping right now, but that looks correct. Yeah, it's just an empty string, it's fine. You don't need to initialize it. It would already return you all the values punched together in a sausage without gaps. Yes. We don't have a exclamation mark operator on the CX string. You need to check whether sep length is 0, for example. Yeah. There are 2 semicolons missing. There are 2 semicolons missing. Yeah. And there is a small bug, but we can see it when we see it. Let's run it. There is already a test case. You just need to run it. Oh, that's of course. The name is wrong. It should be just list, not my list. Lower caps also. Or you can capitalize the other one. Okay, try again. But that was not the error I referred to. Also, you don't need to save when you play. When you press play, it does it automatically. Yes. Wait. We specified this as const, that it's not modifiable, but those are not const. They need to be const. It should be fine. Okay. Wait, I thought we had append. Maybe it's not capitalized. Compare substring trim. Don't we have an append on our string? We do not have an append function on our string. Oh, that's yes. I just wanted to say that sounds like a to-do. Okay, then let's go. Yes. Not between the comment and the function. Above the comment or below the function. Yeah, that's a good place. So append will have a void return value. It should not. It does not need to return anything, because it appends to the current object. It takes a CX string as argument, so it takes what is to be appended. It doesn't matter. It's not Python. It can be. You can write everything in one line. First we need to check whether there is enough capacity in the existing string to append the new string to it. And if there is not enough capacity, then we need to allocate a larger string object, copy the old string over, and then append. I think M arrow will contain capacity. We can just take length of the current object and length of to append. We just add them together and capacity must be large. Although we have to check if capacity is in bytes or in characters, but I think we did everything in characters. So that should be fine. We can quickly scroll down. I will scroll to the here. So capacity is also in characters, so that should be just fine. You just need to check whether mu length plus the other string length is less than capacity. Dot, not arrow. And length needs brackets as it's the function. Right, and if this is larger than capacity, then we need to extend it. I think we have already a function to do some of it. Let's scroll down further. Right, we have create, which gives us a new pointer with a given capacity. So what you need to do is you need to create a temporary variable, assign to it the result of create. You can do everything inside the if, so I just add brackets. Like in very old C, it was customary to have all the variables at the beginning of the function, but this is not really needed anymore, except if you are using goto statements, which you usually people don't do anymore. SX string asterisk. Yeah, p created, for example. The type is SX string. Yeah. You can just write create without anything. So you could go back to the previous. Yeah, there is it. But you need to assign the return of create to pcreate. Yeah. We had a function for that. Okay, no, we did not have a function. But you just first you call release to release whatever was allocated, and then you just assign ms equals create. Without arguments and the semicolon at the end. Yeah, it releases from the current object. But there is one thing missing. We will need to copy the data from M to create before we release M. Now we can use memcopy directly, and then you copy from from m, I don't know, p data or how I called it, or m data, to p data, p create data. So first at the destination, you have two c's, one c. Memcopy has one c in the name. Now when you open the brackets, it should show you what options you have. The first is the destination, so that will be p create error, and then we'll see how I call the variable, p data, comma. Yeah. Now we need the length. Memcopy wants also the length to copy. mu length or something like that. Not on data. Data is just the array. M has the. It will start helping you once you type the error again. Okay, there is two things missing. First of all, we want to copy one more than the length, since we want to include the terminating null character. So +1. And then we need to multiply all of this by the size of one character, since memcopy takes bytes and not characters. Just asterisk size of t. Size of asterisk, size of brackets t, capital T, yeah. Right, and the last thing you need to do is you need to assign p create length being m length, since we don't want that to be null. Before release. Now we have a copy and we can release it, and we need a semicolon again. Mm-hmm. Mm-hmm. P data is of type T. It's an array of type T. You could use memcopy again, just with different offsets. Not quite the right way of doing it. First of all, you need to get the MP data from to append. So just to append is not what memcopy expects. You need to get the internal object out of it. First dot, then arrow. .m. Or you actually could use .c string. That would give you what you want. And then you need to add only the length of what you are appending, not the whole length of the whole thing, but only the length that you are copying. And C string needs to have brackets, since it's a function call, just like length. Okay. And one more mistake, except of the semicolon. Now you will overwrite the beginning of the string, but you want to overwrite where the already existing data end. You can just write plus m arrow ulength. And since it has a specific type, if you add an integer to a pointer, it will actually multiply by the size of every entry if there already is one. So this already gives you an offset at the right position. The only one more thing left to do is to update mu length with the new, but basically just add to it the length of what was appended. Okay, should be working now. Let's try it out. Almost. It must be a typo. Yeah, but I think it's... Yeah. But now it will be used somewhere else, so it will still not compile. You need to find the other releases with the typo end. But I think it was only in the destructor there, not and in the assign operator as well. Okay. No. Okay, let's see what we got as a result. Well, let's try the separ. Wait. There should be a separator. Oh. No. That's at the wrong position. Almost. Not quite. It adds the separator at the very end, but it should only add separators between the values. Just a bit more down. Append is fine. The here. Wait. Yeah. You can move the two lines above the append and then just change the if such that it does not trigger if it's the very first iteration. So we'll just add a second condition to the if. No, but now it will just always have it at the beginning. You need to extend the condition. It was at the right place. You just need to change the if with a second condition to not trigger if it's the first iteration. Well, you have two options. You could either check whether join string is empty, although it will fail if the first value is empty. The other thing is you can just check if pnex is equals to list.getHead. That will be reliable. And since getHead is a very short function, it will be as efficient as checking for length. Mostly. Now it should work. Should I try it? No, we just stop with the normal square stop sign and then we just play again. Like this Hot Wheel builds, that would make sense if you kind of have a program that was already running for some time and then you want to check it. it needs to not be head, not equals but exclamation equals. Yes. Okay, so let's stop this and look what we can do in the remaining 14 minutes. Well, we have a couple to do. First of all, this thing needs to get a proper copy constructor and an assignment operator and a... Alright, there was a bug. Not a bug, but one thing that can be optimized here. We can use const reference. That is better performance. Right, so here we need other what was it? Here we are lazy, then we can use the move move constructor. M, was it M? No, it was head. Head is equals other head. No, not with head, just head per head, and other type is null pointer, and then we need operator. We need say exist is equals this takes other. This will need to be properly implemented. And we need a clear function. That will be a public function void to do. So clear. The structure makes clear, and this makes clear before it does anything. Then we iterate through the other. And append performance wise that's terrible. We can improve on we can improve on that by returning the tail and that doesn't help us. Let's not do append, let's do this manually. So we know that head is empty. So we start with head being tail. Asterisk tail is equals new cx string asterisk tail data is equals pnext data, and now asterisk tail next is equals tail is equals reference on next. Okay, so we go in, we clear, we have our first tail, which is head because head is tail because it's empty. Now we iterate and we add. Yeah, that's efficient enough. So only clear is missing. Let's do this somewhat elegant as well. Okay, so we start with but then we will rename those things. So head is head, Um, head is next. We need the temporary variable as h3 asterisk pair. So we take the value of head, we take preview, we check if this is null. So if this is not null, no, we check if this is null, then we break. So if this is null, then just break. So we don't need this condition here. We just break, and if not, then we have this value, we advance it to the next value, and then we destroy this value. Should be right. This goes one way and it clears everything, so we don't need to care for I should have prefixed this with m underscore. Let's quickly fix this. Wait, now we need to be careful. This remains like it is here. We start with head is okay, tail is done. So once we're done with clear, we can set head null, because everything is null, and tail as well. And here we need to do the same for tail. Okay, other clear initialization is done. This is clear here, copy. I think everything's fine, let's try it out. So let's exercise our copy constructor and let's put this in the scope so that we test the destructor as well. Okay. I think this is not supposed to be const in this case. Right. Okay, so this is rather boring. It's just a constructor that doesn't do anything. Then we have our assignment operator. No, first we have other things. Then we have the split. Okay, but split is good. Let's step. Let's put a breakpoint here. Now when we step inside, we did not step into the move operator. That's not ideal. Why did we do that? It might be that it would just abstract it away. Debug window, disassembly. Continue. That's too much. So we have our char. We have here the split function. We want the breakpoint here. Okay, so let's see. Okay, this actually optimized the way this part, so this works fine. So it just knows it always returns one object and then just uses the memory that was already provided. So this is efficient enough. So let's now test the assignment operator. Okay, so we clear, but there is nothing to clear, so this doesn't do anything. Now we step through the thing. And here we assign data each time. Data is not a pointer, data is an actual string, so this should be fine. Okay, so then we return from this. Now in CList, you will be clearing something. Looks valid. It doesn't look valid. We have some issue here. Let's think again. So we start with head, right? Then we take the value of head to preview. We check, and this is fine. Then here we assign head with next. That's the problem. Where do we assign head with? The problem is, and once we delete this, the other thing is no longer valid. So we don't need to modify those things. So let's go with this approach. Brief is just head. Now it should be fine. Let's put a breakpoint here. Just stop it completely and try again. What? Is it complete? Apparently this is a really odd bug. Let's just rebuild everything. Rebuild solution. Okay, now it's fine. Right. Now we are here. We are deleting one element, the next one, and the last one, and one more. Yeah. Okay. We delete everything. Perfect. It's working. Then we delete this. And we have 1 minute left. So the homework assignment will be 14/11/2024. Append and prepend will also be nice to have. No, this is too trivial. Prepend function, because like the prepend function is will we need prepend for something? I don't think so. Let's keep it here. Complete the prepend function. So Okay, is that assignment clear? Any questions? No questions? Okay, yeah. You want a square bracket x from the cx string to get the one character, or do you want it from the list? Okay, so to get one character, that's actually quite trivial. I can quickly add this. Here, const t. We don't need const, just t. And we could make const t reference operator. Sorry, square brackets, and that's the right syntax. So const x const, then return m p data at position. So we can change this to just be like this, because it just returns a copy. And then you have an operator which will return you the character at the position you specified. You cannot specify in a square bracket operator anything other than some sort of index or key. It's not intended to asked in the chat to make this somehow generate multiple objects. What you can do is, if you want to be able to modify t, is to have t reference, then it's no longer const, and then you can modify whatever in p data. But of course, what we need is a check if this is a valid position. In the uppercase, this is trivial because we just check if pos is greater equals than length, then we just return 0, the null character. Here it is more complicated because we would need to grow, if needed, the string so that the character is available. Because since we return a reference, we always must return something valid. We could throw an exception, of course. We could have here a check which throws an exception instead of growing the string. But I think for our use case it would be simpler if this would just grow the string as needed. Any more questions? So yeah, in the square bracket operator, we are using the argument as a position. Yes. I'm not sure what the questioning user in the chat wants to know exactly with regard to the square bracket operator. It is not commonly used to generate a list or to split or anything. It is just used to index things in an array, or if you have a map, then you can use a arbitrary type as key to access it. So the way to use this operator, let's say we have somewhere a string is, let's say 2. So if 2 is equals 2 is the set c, then that's how it works. Okay, that solved the question. Any more questions? Okay. Okay, there is another question in the chat. So the implementation, if one wants to use this square bracket operator on any other type, works quite analogously. You just define your square bracket operator with whatever type as argument you want, and then you return something that semantically makes sense with the contents of the other object. So in principle, if our list would be a vector, we could have a square bracket operator to get entries at this position. So what we can do in one of the next exercises would be to implement an own X vector, which would then allow us access by offset, and then we could use the square bracket operated there. Okay, any more questions? Okay, then we are done for today. I will upload the new project, the improved project, and the recording and the homework to Moodle, and we will see each other in a few hours for the lecture. Bye bye.